Alrighty, well, we'll work one last problem, just one more example in case you need it. So, and this is similar to the last one that we worked. It's got two different things changing, and you just have to deal with both of those separately. So, a methane bubble with a volume of 2.82 milliliters forms at the bottom of the lake where the pressure is 4.6 atmospheres and the temperature is 15 degrees Celsius. So, as you know, we can't use Celsius, we have to use Kelvin. So to change from Celsius to Kelvin, we add 273. So our actual temperature is 288 Kelvin. I'm going to go ahead and put all that information in my PVTn chart, and that's my initial condition. So the methane bubble has a volume of 2.82 milliliters. The pressure is 4.6 atmospheres. And the temperature is 288 Kelvin. What is the volume of the bubble? So there's my question. When it reaches the surface where the pressure is 0.983 atmospheres and the temperature is 28 degrees Celsius, again, can't use that. So I add 273, and that gives me 301 Kelvin. Alrighty. So it doesn't say anything about the number of particles changing, so I'm going to ignore that part of my chart. And then I'm going to look at what's happening in this problem. So I look at the pressure. The pressure went from 4.6 to 0.983 atmospheres. So I've had a decrease in pressure. So I put a down arrow there. When pressure decreases, volume is going to increase. So again, that is my only inverse relationship. And I'm going to label this arrow, since I've got two things changing, with a P. So because of the pressure, the volume has to go up. So that tells me how I set up those pressure numbers. Now, the temperature in this case went from 288 to 301. I've had a temperature increase. When temperature increases, the volume also increases. That's a direct relationship. So I'm going to put another up arrow, and I'm going to label this one with the T for temperature. So in this case, both of the changes are going in the same direction, and so that just tells me how I set up the numbers to do my calculation. As always, I'm going to start with what I'm looking for. So the original volume is going to have to change by some factors that are made up of these variables. So 2.82 milliliters. Because of the pressure change, the volume is going to go up. That means the bigger number goes on top of the pressure factor. So 4.6 goes on top, 0.983 goes on the bottom. Because of the temperature change, the volume is going to go up even more. So again, the big number goes on top. 301 Kelvin over 288 Kelvin. Again, notice these units are going to cancel out. I keep a volume unit. So to solve that, I multiply everything that's on the top. I divide by anything that's on the bottom. So 2.82 times 4.6 times 301 divided by 0.983. Then divided again by 288. And that's 13.79, etc. I'm limited to two significant figures because of that pressure unit. So I'm going to round that to 14. My unit is milliliters. And that's my answer. And again, just make sure it makes sense. I started at 2.82. I had an increase and an increase. And so my final answer is definitely larger than my initial answer. So that tells me that I've got the math set up and that I'm on the right track there. So again, that's the last example. You can move on to those practice problems and submit your answers to those this time. I didn't give you the answer key, and we'll talk about those next time. See you soon.